us to start the class. Just start the class. So today we are again. I'm repeating some notes on homogeneous equations because last time we were not able to go through. There were so many questions on separation of variables, which I believe is a bit now clear. So we are saying that homogeneous equation is of the form. Is of this form. I've already given you the notes. P. P dy all over dx is equals to q, where p and q are functions x and y. So basically the homogeneous equation. But again, we are saying for the homogeneous equation, the p and the q, they have to be of the same degree. The p and the q of the same degree. So p and q the same degree. Remember very well, for the degree it was the power, and I can be able to give you an example of an equation that is homogeneous. So for example, if I say for example, this one is not just an example to demonstrate that if we have this one, f of xy is equals to x squared plus y squared plus xy. That one is a homogeneous equation. It is a homogeneous equation. That one is a homogeneous equation. Why? This is the reason. We shall pick each term individually, and you will be able to see. We pick each term. So we can go to start with this one, x squared. What is the power here? If I draw a table, let me draw a table. At least I can be able to show you. We draw a table here. Demonstrate that. That's the example. You are saying it is homogeneous, and you want to show why. So let me draw a table here. We have here a function. We have here a function. Then we have power. We have the first one, x squared. Then we have y squared. Then we have xy. So what is the power of x squared? We can start there. X squared. What is the power of x squared? Yes, Oscar. You can still be able to say something on the mic, as long as I'll be the one who will be calling the people to say. So it's not a must write. You can go on the mic. You can just activate your mic, and then you'll be muting when there's no need. So what is the power of x squared? No one is okay. Someone has written, so I'll go with that answer quickly. That is power 2. So that's correct. Power 2, and you can be able to agree that one is of power 2. Let's now go to xy. So this one is of power 1, the x, and this one is of power 1. So the total power will be 1 plus 1 is the same as what? 2. So you are dealing with the power. Even if you have x and y, if x is of power 1 and y is of power 1, what we are doing, we are adding the powers. We are adding the powers using the laws of indices. So we still have power 2. We still have power 2. Let me give you one to try and tell me if you'll be able to get this one correctly. Is it homogeneous or not? So even if you have x, y, the x and y, you consider each individual power, then you add the 2 powers to get power 2. So let me give you another function. Tell me if it is homogeneous or not. Is equals to x to the power 3 plus xy squared. That one there, tell me if it is homogeneous. Tell me if it is homogeneous or not. That one, is it homogeneous or not? Is it homogeneous or not? I want to hear some people speaking. You can be able to activate your mic and tell me the answer. It is even quicker. Okay, I'm seeing some answers. Yes. Because if you don't get this one, then you shall not be able to do the other questions. Yes, it is. Yes, it is homogeneous because all of them are of power 3. So we have x to power 3. This one has the power 3. Then we have x and y squared. This is power 1. So you get the power is 1 plus 2 to be what? 3. So it is homogeneous because it is corresponding. Final one. Let me give you another one. 3. That one there, is it homogeneous? Is it homogeneous? That one, you can try. Is it homogeneous? That one? Yes, Mokenya. Leonard, is it homogeneous? Pardon? I've not gotten you. Is it homogeneous, Leonard? I
Yes.
don't. Yes. Okay. Leonard has said yes. Okay. We can be able to get another answer. Is it homogeneous? Yeah, you guys are taking time to type. Is it homogeneous? Okay. Taking a lot of time. Type. Yes, Barasa Peter. Is it? People are muting quickly. Okay. Now, I've seen another answer. Yes, it is. Basweti Ndege has said no. Let me hear some answers. Muturi Harrison has said yes, it is. Moses Ratemo, not. It is not. That is Bonyo. Luko Faith, no. Okay. Let me give you my final answer. So we shall have this one here. I'll have x, that is of power 1. I have xy, that is power 2, because we are adding the power, that is 1 plus 1, you get 2. Then we have y squared. We have y squared, that is of power 2. And finally we have, the constant is not playing any part. So even if we have that one, it's not playing any part. So I'll have still power 2. So this and these are matching, but this one is not matching. So what we can be able to say in short is that it is not. It is not because of x is of power 1. X is of power 1, so it is not. Simple as that. Very simple as that. X is x. It is not because x is of power 1. The rest are of power 2. Check again the question. Check again, check again, check again. We have x. So you deal with the individuals. You deal with the individuals one by one, and then you determine. So don't be in a hurry. I give you the final one now. That one there. Is it homogeneous or not? Sorry. Is it homogeneous or not? That one there. Paul Monene, what is your answer?
It is not.
It is not. Okay, Sawa. I've gotten one answer. Anyone else wants to speak? Just speak. Barasa?
It's not a homogeneous equation.
Okay. I've got. I am mute quickly. Okay. Chep Kemoi, Maureen. Chep Kemoi. Karakacha?
Not homogeneous.
Okay, so. And you guys now are getting it now. At least now I can be able to see. Basweti, hey, just mute. So I think I've gotten. Basweti?
It is not an homogeneous equation.
Okay, Sawa. Kirwa? Okay, Sawa. True, not. Because of what? Because of this function here. This function here, let me put it in blue, this one. This one here is of power, that is power 3. These are, if you add them, they'll be power 4. This one is power 4. This one is when you add those powers, it will be power 4. So because of one function, it is not what? It is not homogeneous. It is not homogeneous. It cannot be homogeneous just because of that. So how do we solve homogeneous equations? How to solve? Mute. Kindly mute. Angela Sharon, kindly mute. Kindly mute. Kindly mute. We continue. Angela Sharon, kindly mute. So I'll have this one. How do we solve these ones? How to solve? How to solve? Introduce. Not really introduce. We let. Just let's. We let y to be given by v times x. Then we differentiate using product rule, because now in our equation we shall have a dy. So we want to replace y with vx, so we shall again replace even dy. So this one they are using product rule. Remember product rule, you differentiate one and you leave the other one a constant. So this one I'll get here dy is equals to, then I will leave the v as a constant. When you differentiate x, you get dx. Then I will leave what? I will leave x as a constant. Then when you differentiate v, you get what? dv. So this is the function I'll multiply it. So this function will be given by v dx plus x dv. I've used product rule. Differentiate one, leave the other function as a constant. So when you differentiate y, you get dy. Now, The functions that are in blue are the ones that have differentiated. If I'm able to use a different pen. So these ones are the ones that have differentiated, the ones that are in red. So product rule means you differentiate one, you leave the other one as a constant, vice versa, and you continue like that. So we use product rule, we let y to be vx, then we use product rule. Almost similar to the one of y is equals to ux. But remember here we don't have dy over dx. We are just differentiating the y to get dy, and the v to get dv, and the x to get dx. Those are the ones I've differentiated. After you do that, you replace now the u and the v in the equation. Then after you replace the v and the u, we shall integrate. And after we integrate, after we are finished integrating, we shall again replace back the value of y. Remember, our equation will not have, no, we shall replace back. So the second step, that is the first step. That's the first step. Sorry for that. So that's the first step we have done, is to introduce the vx. Step number 2, what we shall do after we replace the y and dy, basically we replace the y and the dy with what we have there. Then after that we shall integrate. No, we shall do separation of variables. We learned this one last time. We do separation of variables. You know, it's just the integration. Then we integrate, and finally, the final step, since y is equals to vx, we shall replace back the v. The v was not there, so v will be given by y over x. So you're introducing something to Ferdinand, kindly mute. We are introducing something to assist us. So after replacing the y and the dy, separation of variables, we integrate, then we replace back. You remember, it is as if integration by substitution. We're introducing a u, but later on, you are coming again and replacing the u with what we had. I'll do the first example just to demonstrate. I'll do the first example just to demonstrate. So can we just do an example? We go step by step. Today we shall be, at least because you learned last time we overstayed, today we are not really overstaying. So this is what we have. Y minus x. I just do the example that I have. Y minus x is equals to x dy dx. X dy all over dx. That is what we are supposed to solve. That's what we are supposed to solve. First of all, I'll ask, is it homogeneous? We start from there, because we must first of all check if it is homogeneous. So how do you check? We check on the powers. So this one is of power 1. This one is of power 1. And the x is of power 1. So it is homogeneous. It is homogeneous in that. It is homogeneous. Now, after doing that, what the next step we need to do is to bring the x and the y, the dy and the dx, they have to be on the numerator, because we shall be able to replace them. So when I cross multiply is what I'll be able to get. And brackets are very important here. When you cross multiply, this is what I'll get. I'll get y minus x, and then here dx will be the same as x dy. Always make sure that your dx and the dy are on the numerator. And because we have y minus x, we must be able to put the brackets. Very important. Now, the first step we said is to introduce a vx. We replace y with vx and we replace dy with what? You remember product rule? So this is what we shall be able to replace with. So we said let's y be what? Y be given by vx. and let dy be given by product rule means what? Differentiate one, leave the other one as a constant, then we do the reverse. This we shall get x dv. X dv. Can you start? Can you start with x dv? Yes, you are allowed to start with x dv because you have addition. There's no problem. So I will replace everything with that. So where there's a y, I replace with that one, and where there's a what? There's a dy, I replace with that one there. So the first one I have here is what? Is vx minus x times dx. On this other side, I'll have the x will remain the way it is, but the dy I'll have v dx plus x dv, like that. So I've replaced the y with vx, I've replaced dy with v dx plus x dv. Open up the bracket, what do we get? So we shall get vx dx minus x dx is equals to xv dx plus x squared dv. Now, can someone see a term that will go? Can someone see a term that will go to zero? Mostly in these equations, there'll always be a term that will go to zero. Mostly of the equations. If you have gone through the examples, there's a term that will always go to zero. So are you seeing the term that is going to zero? Anyone who can be able to see? Leonard, I can see you are in. Anyone who can be able to see a term that will go to zero? Okay, let me circle the identical terms. So these terms, check this one out. This one here in circle and this one here, they are identical. It doesn't matter. Remember, Vx and Xv, they are the same. Vx is the same as Xv. No problem. So all of them are positive on the is equal. So when one will go this other side, you shall remain with what now? You shall remain with this now. They are identical, those two. They are. So we shall remain with negative x dx is equals to x squared dv minus x dx. So this one, that one, let me put it in blue, it has gone to zero. Why? That one has gone to zero and that one there has gone to zero. Has gone to zero. So from there now we do separation of variables. The problem we have x squared with the dv, so we can't integrate the x squared with the dv. The x squared has to go on the side of what? Of dx. So we do a separation of variables. We did this one last week. So on separation of variables now, separation of variables. When you do the separation, that x squared has to go this other side. So this is what we shall be able to get, negative x all over x squared dx is equals to dv. Is equals to dv. Now from there we can be able to cancel. So here you can remain with what? Negative 1 over x dx is equals to dv. Now you can be able to see that the x and the dx are on one side and the dv is alone. Then from there now we can be able to integrate now. Now we can be able now to integrate now. We integrate and we integrate. When you integrate 1 over x, what do you get? So you'll get negative ln x. When you integrate dv, you'll always get what? V. And then plus a constant of what? Integration. So remember when you integrate dx, dx, you get what? You get x. When you integrate dv, you will get what? V. Now we are almost done now, but y is equals to vx, which means that v is equals to what? Y over x. So that will be negative ln x is equals to y all over x plus c. And I'm done with that one. And I'm done with that one. So you must be able to replace back, because in our equation we did not have a v. The v was to assist us to be able to come and simplify and get the solution. Anyone with a question there? Or I go to the second one? Anyone with a question? Sorry. Anyone with a question?
Yes, sir.
Yes, ask the question. Yes, Kevin.
I don't have a question. I was saying that it is clear. We can continue.
Someone is saying I repeat. Teacher, you can repeat. Okay, I'll have to repeat again from the beginning now. Give me a moment. I'm looking maybe for another example that I can be able to easily do. So let me just repeat again. So if I go back, so this is the example we had said y minus x is equals to, it is homogeneous, y is of power 1, x is of power 1, and another x is of power 1. So I said we cross multiply to bring the dx on the numerator. So we have y minus x times dx is equals to x dy. Then we said we always introduce the y is equals to vx, and then dy is equals to v dx plus x dv. Then if you introduce that one, you replace the y with vx, introduce the y with vx. Can be able to see I've replaced with vx there. And then I've replaced now the whole of dy with that one, whatever that I've circled in blue. Then from there, I open up the brackets. Vx times dx will get vx dx minus x dx. X times v will get x times v dx, and then x squared dv. These two terms that I've circled in red, they are identical, and they are on opposite sides of the is equal. So they'll go to zero. If you bring one term on the left hand side or on the right hand side, it will subtract the other term. They are equal. So what I remain with is negative x dx is equals to x squared dv. In the last class, we said separation of variables. You can't integrate straightforward like that. You must separate the variable. The x with the dx. If we had a v, the v will have been with the what? With the dv. So I separated the variables by bringing the x on the side of dx. So I divided both sides by x squared. So I remain with negative x all over x squared. You can be able to see. And then on this side, you just remain with dv. So when you cancel, you'll get negative 1 over x dx is equals to dv. Now you can be able to integrate because you have similar terms. So when you integrate negative 1 over x, you'll get negative ln x. When you integrate dv, this one here, when you integrate dv, you just get v. But again, you must go back. In our equation, we did not have a v. Remember, the v was to assist us. In our equation, we did not have this v here. It was not there. So it was to assist us. So we must be able to go back to where we started from. Our y is given by vx. So using this formula, I can be able to get the value of v. And the value of v is what? Y over x. So I replace back the value of v, and I am done with that equation. I replace back the value of v, and I'm done. Let me do another example. I need to pick another example that you have not. Another example that maybe is not there in the notes, just to demonstrate. I'm looking for one. Give me just a moment. I just pick one that's not there in the notes. We try to do it, but it's as if I cannot be able to find him. So just pick an example again in the notes as I look for one that is a bit new. Because I really wanted to do one that is new for you. Let me try this one. I've seen one. Let me try this one. So this is what I have. Dy dx. I've seen one. Pen dy all over dx. That is not there. Dy over dx. Negative 2x plus 5y. Negative 2x plus 5y. I hope it will work out. All over all over 2x plus y. All over 2x plus y. All over 2x plus y. So you can be able to see again, this equation is homogeneous. Why is it homogeneous? Because of this. So the x here is of power 1, the y here is of power 1, this one is power 1, power 1. So you take the individuals. So this one is of degree 1. So we consider that equation to be homogeneous. Now from there now, we said what we introduced. We said let y be uv. So dy will be given by, yeah, I'm confusing, not uv. I've gone back to product rule. So we are saying that y will be given by, we said xv. So when you differentiate this one using product rule, you get x dv plus v dx. We said the order doesn't matter. The order doesn't matter. You can start with v dx or you can start with x dv. The order doesn't matter. But before I do that, let me first of all cross multiply and see what I'm getting. Cross multiply. You cross multiply and see what we are getting. So the first one I'll have what? 2x plus y dy. You can cross multiply the way you want. Then negative 2x plus 5y dy what? Dy. That's what I have. Sorry, dx. Sorry, that one is dx. That one is dx. This one here, it is dx, not dy, dx. So we said first of all, we cross multiply and get that. So that's what I'm getting first of all when I cross multiply. That's what I'm getting when I cross multiply. Just continue. I'm hoping it will. Not all equations can be solved with this method, but let's try and see. So from there, one is a bit tedious now. We need to replace where there's an x with what? Sorry, a y with xv, and where there's a dy with that one. So it's a bit big. So the first one I'll have 2x plus xv, and then our dy is what? X dv plus v dx. Be the same as the other one. I'll have negative 2x plus 5. Our y is xv, and then our dx. So I'll open up the bracket. Open up the bracket for the first one here. So I'll multiply 2x, this one with the whole of that one, and again this one with the whole of that one, for me to be able to get it. So when you multiply that one, you are getting what? 2x squared dv, and then plus 2x, 2x what? 2xv dx, and then plus x squared v dv, and then plus x v squared dx is equals to, this other time when you multiply, you are getting negative 2x dx plus 5 is a lengthy one. Is a lengthy one. And just to use, just repeat this one so at least I can be able to have more space. There's nothing wrong I've done. So the final one I had gotten was plus x squared. It was no. Let me see. We have got the first one. Then I got 2xv. Then I got x squared v. So I should be getting xv squared. Xv squared means x v squared dx will be the same as negative 2x dx plus 5xv dx. That's what I'm getting. That's what I'm getting. We try to bring like terms together. I've just taken an example. I don't know if it will be able to work out. So we bring the dv and the dx on one side. So if I bring the dx and the dv on one side, let me see. So I'll have 2x squared dv. Another function of dv is this one, x squared v dv. I have another, do I have another function of dv? I'm done. That is the functions of dv. Let me see the functions of dx now. The functions of dx, I'll start with what I have here, that is negative 2x dx plus 5xv dx. And then there are some terms that will go on the right hand side. So the first one is negative 2xv dx. And then I have another one, minus x v squared dx. So that's what I'm having. Can someone see like terms together? Yes, there's a like term together. There's a like term together. So this is what we shall be able to get. 2x squared dv plus x squared v dv. These two terms here, we can be able to subtract them. So if I subtract those two, this is what I'm remaining with. I'm remaining with negative 2x dx plus 3 plus 3xv dx, and then minus what? Minus xv squared dx. So this one was it's not writing, it was 2. And then we have a dv. And that's what we have. So now this one, we need now to factorize. We need a bit of factorizing. We factorize. Factorize. So when you factorize the first one, on the side of dv, we want to remain with v. So I can be able to factorize the x and the dv outside. So if I remove the x squared, this is what I'm remaining with. because I want to remain with dv this side. So I'll remain with 2 what? 2 dv plus what? V dv. That's what I remain with on the right hand side. On the other side, I want to factorize the what? I want to factorize the x first of all, because the x is the one that is common throughout, and the dx. So I can be able to factorize the x and the dx. Take what I remain with. I remain with the negative 2 plus 3v, and then this one is what? Minus v squared. That's what I'm remaining with. So you factorize the like terms. So in the first one, the like term was the what? I could even have factorized the dv, but no problem. The like terms was the dv and the x squared. The other one was the x is the one that was common. Now this one I can be able to simplify this one. I've done a hard example. So this one I can be able to have look something like this one, x squared, and I can have 2 plus v. Then I'll have remain here with the dv, because dv is still common, is equals to now what? This one is equals to, I can write it in a better way, x negative 2 plus 3v minus v squared. Then I'll have here a d and dx. Like that. Did I do a mistake? I don't think so. That's what I'm getting. This one. So I do the separation of variables for this one. I bring the dv on one side. Already I have the 2v, 2 plus v will remain there. So I'll bring the x this other side. So this is what I'll be getting if I separate the separation of variables now. So I'll have here v plus 2 will remain that side all over. Negative v squared, I'm rearranging it, plus 3v minus 2. And then here dv is equals to x all over x squared dx. That's what I'm getting. That is what I'm getting. That is what I'm getting. Because you have minus 3 plus 3 minus 2. Now, after you have done the separation of variables, now we need now to come and integrate both sides, because we have like terms together. So integrating, but before I integrate, let me first of all simplify. So I'll have v plus 2 all over negative v squared plus 3v minus 2 dv is equals to 1 over x dx. This side is very easy to integrate. The right hand side, this one. This one is easy to integrate because this one you will get what? ln x plus c. But what about now the integration of this one now? How do you integrate such function? Can someone see? Because now the integration is the most important. That's why you are learning integration techniques. How shall we be able to integrate that function there? Someone who can be able to see a light? I'm lost. How do you? Before you go far, sir, I'm lost. Substitution, I'm not getting you, sir. Okay, I'll have to start all over again. Okay, sir. Let's start all the way from the beginning. It's a hard example, I think I want to pick, but it's still okay. So we are saying all of them are of the same order, you can be able to see. Then we said we introduce y to be xv, and then x dv plus v dx for the dy. Then we're able to replace. So I was able to cross multiply my equation. You cross multiply so that the dy is on the numerator and the dx is on the numerator. So when you cross multiply, this is what I was getting: 2x plus y dy is equals to negative 2x plus 5y. Then I was able to replace back. This is what I was able to replace. I was able to replace, you can be able to see here. I was able to replace the y with xv in yellow. Then the dy, you can be able to see. The dy is the whole of that one. Is equals to, again, the 2x doesn't have y, it will remain the same. Then you can be able to see here again on the y, I've replaced with what? Xv. Then I was able to open up the bracket. So you multiply 2x with the whole of this one, then you multiply xv with the whole of this one. So when you multiply 2x times x, you'll get 2x squared. Then you multiply 2x times v, you'll get 2xv. Multiply xv times x, you'll get what? Xv times x, you'll get x squared v. And then you multiply xv times v, you'll get xv squared dx. This side is straightforward. It is easy to open and see and get that one. Now from there, I brought the like terms together. Whatever that has this one here, the one in yellow here. Let me put it. The one that has dv, I have another one here dv. Those terms, they remained where? On the left hand side. You can be able to see. They remain on the left hand side. Whatever term that has dx, I took it where? On the left hand side. So these are the terms that I had. Then when a positive will cross over, it became a negative. Again, when a positive crossover, it will become a negative. That is what I have. Then whatever that I've circled here, these two terms are identical. So 5xv minus 2xv will remain with what? 3. When you do that subtraction, you remain with 3xv. The same thing that I have here. Then I was able to factorize. So you factorize here, what is common, we have x squared and dv. So you can easily be able to factorize even the dv. Let me just rub this one. You can even factorize even the dv here. You don't need this one here. You don't need this one. You can easily even factorize the dv here. Just factorize even the dv. The common term is x squared and dv. So you remain with what? You remain with 2 plus v. Those are the left terms together. So when I write like that, I rearranged. Check, I have 2 plus v. It's just a matter of rearranging. I have x squared. You can be able to see the 2 plus v is still there. Then the dv is still there, is equals to. Then we have the x. Here, what is common here? Let me check, go back. What is common here? Now we have negative 2x dx, 3xv, and negative. So what is common here is what? The x and the dx. So I was able even to factorize the x and the dx. So I remain with the whole of that one. Now from there now is separation of variables. So the whole of this one, negative 2 plus 3v minus v squared, it will go on the side of dv. So you divide, it will come this side. Now the x squared will come on the side of dx. So I'll have to divide with x squared here. When you simplify that one, you get 1 over x. This one you remain with v plus 2, and then negative v squared plus 3v minus 2. Now I was on the point of saying that integrating the right hand side is very easy. You'll get ln x plus c. But what do you do? How do you integrate this one, a function like this one? That's where I wanted at least some ideas from me. How do you integrate that one? Use integration by substitution, completing the square. I don't think so. We said first of all, before we go to completing the square and integration by substitution, substitution can't work because when you differentiate a v squared, a negative v squared will get negative 2v plus 3. They can't cancel. They can't cancel. For me, I don't know why. Pardon? I don't know why I
I'm
thought.
not getting your.
You're not getting my voice. Are you getting me clearly now? Some people are saying they're not getting me. So this is where we are. How do you integrate this function? How do you integrate that function? That's where we are. Because you have done separation of variables, you've introduced y is equals to vx, we are substituted back even with the dy, then we separated, then we factorized. This is what we are ending with. So we want to need to do what? to do what? To integrate that one. Let me first of all check if it can be factorized. That's where we start. We check if this one can be factorized. That's where we start. This one here. Start where if to see if this one can be factorized. If it can be factorized. That's where I will start. So here the product here is what? -1 times -2 is the same as what? 2. The sum here is what? 3. That's two numbers. Two numbers that you multiply to get 2, and when you add, you get 3. Can someone give me those two numbers? That's what me I will start with. I will start from there to see if that one can be factorized. If it can be factorized, we can be able to use what? Partial fractions. Two numbers you multiply to get 2, and when you add it, you get 3. Okay, 1 and 2. Okay, someone has given me the answer 1 and 2. So 1 and 2. So it can be factorized. Then it can. That's where I will start before I go to that one. So I'll get negative v squared plus 3v minus 2. Now nani huyo anaongea kwa nguvu hivyo na
Mwalimu, as I was saying, it's I'm not getting anything, even the board.
you're not getting the board.
Yeah, I've been trying to text, so yeah.
No,
I've been trying to text you from the beginning. I've not gained anything since you started the second example.
so don't worry. I'll do another example, and then
So
there's a
please
record.
revive the second example. I'll be very much grateful. It's Kayamba.
No problem. Is it possible for you can be able to follow the
But I
recording
heard you
later?
saying it was a little bit that example was somehow complicated.
Just a bit. Okay, so I can still be able to repeat. Can you see the board now? Can you see the board? Let's confirm first of all. Can you see the board?
No, it's still loading, I think.
It's still loading.
Yeah.
Now, can you see the board now?
Still not yet, sir.
Let me confirm from your class members. Anyone who can be able to see the board, they can type because it may be having a network issue at your place.
Yeah, now
Pardon? Can you see now the board? If you can be able to see the
I
board,
can be able to see, sir.
now you can be able to see. Okay. Sawa. Okay, let me start from the beginning again.
From the factorize,
You will be able to get it after around 30 minutes. So I'm now on the side of factorizing. So when I factorize, I've added negative v squared plus v, then I've paired the terms. When you pair the terms, this is what I will get. This is what I will get now when you factorize. Here you'll get what here? What is the GCD here? I can say negative v. So I will remain with what here? V minus 1. This other side, the most common term is 2. So I'll get v minus 1. So this one I'll get it as the same as what? Negative v plus 2. And then v minus 1. So I think partial fractions will be able to work. So partial fractions, because you can easily factorize. So I'll go back to the equation that I have. So I'll have v plus 2 on the numerator. I'll have v plus 2 all over negative v plus 2. And then v minus 1. Remember, partial fractions will introduce this one a, negative v plus 2, and then plus b, v minus 1. We look for the value of those two. So factorize this one. So the LCM here will be what? Negative V plus 2 and then V minus 1. So I remain with A, V minus 1 plus B, negative V plus 2. So because they are identical, these two, I'm able to see they are identical, it can only mean that what? That V plus 2 is the same as A, V minus 1 plus B, negative V plus 2. I try to eliminate, I can choose a value. I can eliminate A by choosing what? By choosing V to be what? V to be B when V is equals to 1. When V is equals to 1, we shall get 3, A0 plus B, negative 1 plus 2. So it means that 3 will be given by B1. So B will be what? B will be 1. And then I can choose another value to eliminate what? B by choosing it to be 2. So I'll have what? 2 plus 2, that is 4. And then A, 2 minus 1 plus B, negative 2 plus 2. When you do that one correctly, this is what I'm getting. A will be the same as 4. The integration now is a bit easier now. Instead of having that, this is what I'll have now. So my A is 4. So I'll have the integration of 4 negative V plus 2 dV plus my B. My B is what? My B is 3. What did we have on the B? On the B, we had on the denominator, we had what? We had V minus 1. We had V minus 1, V minus 1, V minus 1, again that one dV. So partial fractions will work. So this one is partial fractions. So on the integration of that one, it is easy. The first one here, this one here, I can be able to remove the negative outside so that you can be able to see it clearly. So I'll do each term. So 4 all over negative V plus 2 dV. This one is the same as, I can be able to remove the negative outside with the 4. Then I remain with what? 1 all over V minus 2. I'm making it easier for you to be able to. So I've removed the negative outside. I've factorized the negative outside. So when you integrate this one, you'll get negative 4 ln V minus 2. The other term that I'm having is 3 V minus 1. 3 V minus 1 dV. This one is straightforward. You'll get 3 ln V minus 1. So I can be able to add all the terms now. So the final answer will be negative 4 ln V minus 2 plus 3 ln V minus 1. What we got on the right hand side was what? ln x. And then we add a constant of integration. Last time we said ln what? ln c. That one is what we shall be able to have. Now using some laws of what? Logarithms, because we have logarithms everywhere, we can be able to combine all this. So this one here, the first one here, I'll have the same as ln. I know the example is lengthy. So let me just rearrange it. So I'll have, let me rearrange it so that you can be able to see it clearly, because if you don't see it clearly, but if you can be able to reach there, I'm comfortable, but I can still be able to make it a bit better. So 3 ln V minus 1 minus 4 ln V, I've started with a positive one, is equals to ln x plus ln c. That's what I have. We have said if you are not following, the recording will be there. B is not 3, not 1. Okay, let me confirm again. B, where is B? Where is B? B, we have replaced 1. So 1, can you confirm the value of B? So here, So this is where we are. So we have replaced there with 1. So I was getting 1 plus 3. Sorry, 1 plus 2 is 3. 1 minus 1 is 0. Then negative 1 plus 2. I thought that is the same as 1. So I'm getting it B as 1. Can students confirm they have gotten the value of B as 3? Is it okay? People had some issues. Oh, yes. Oh, is 3. Okay, so okay, I've seen where I had done a mistake. It is okay. B is 3. B is 3. Oh, it is I who had done the mistake. B is 3. So B is 3. But I think I've used 3 down there. So no problem. I've used 3. So, and A is 4. So I've done that one, the integration of that one. So I want to give you a better answer because we have ln. Last week we had dealt with such an equation when you have ln elsewhere. So this one is the same as ln v minus 1 raised to power 3. I'm using some laws of logarithms minus ln v minus 2 raised to power 4 is equals to ln x plus ln c. Now I can be able to combine now. When you have a minus on the logarithms, this one is the same as ln v minus 1 raised to power 3 all over v minus 2 raised to power 4. When you have a minus, you divide. When you have a times, when you have, sorry, addition, you multiply. xc. Now this one I can easily be able to replace now because I have ln and ln. I can still just be able to say that v minus 1 raised to power 3 is the same as v minus 2 raised to power 4 is the same as xc. That's the reason why I was introducing logs everywhere, even on the constant. I'm almost done now, but y is equals to vx. So v will be the same as y over x. So I replace that one and I'm done. So I'll have y over x minus 1 raised to power 3 all over y all over x minus 2 raised to power 4 is equals to xc. You must always replace back. So maybe what we can be able to agree with, that you must be able to go back to integration techniques. If you want to do these equations, you must be able to go back to integration. If you not be able to get the integration, you'll have a lot of problems, because I was supposed just to give you the answer. But you see, now I've been able to do one by one, so at least you can be able to get it. So make sure you go back to the techniques of what? Techniques of integration. You can be able to do it. Let me do at least an example that is in your book that is not that hard. Then I will leave the rest. If you have any problems, I'll be able to get back to you. Let me do this one. This one is a bit easier. But what we are doing is very simple. Introducing y is equals to vx and replacing by dy. The other things we learned in the other class. Separation of variables. So let me do one that is maybe a bit easier for you to be able again to follow. This is what I have. That one was a lengthy one, but it was worth it. X dx x dy all over dx is equals to x squared y squared. All over y. Let's start. Is it homogeneous, this one? You can start from there. Is it homogeneous?
It is not homogeneous.
Someone is saying it is not homogeneous. Okay.
No.
Yes, Barasa Peter. Basweti. Is it homogeneous or not? We start from there.
It is not.
It is not. Okay,
It
so
is not homogeneous.
it is not Sharon. Okay. I will say it is. It is homogeneous. It is. So for my sake, it is homogeneous. Let's go back to the previous examples and check what we are doing. Because if you can able to understand from the previous example, then it will be much easier. Because if you just take it by, let me go back up. Let's start from the where we started, homogeneous. So P dy dx is equals to Q. So you can be able to see here a function of xy. So we have fxy on one side and the function. And we said the first one it was what? Homogeneous. Even this one you said it was homogeneous. You can be able to see fxy is equals to x plus xy like that. Someone is mute kindly. Then we did an example, this one here. So this one is how to do it. Let me go back to the first example we did. So you can be able to see this example. We don't have a denominator, so we had 1, 1, 1 for them. So this is something I had not mentioned that was very critical. So by looking at it, this example here, you may assume that this one is for power 1, power 2, and power 1. That one will be wrong. But there's a way you can be able to arrange this equation for it to become homogeneous. Check this one out. Check this one out, rearranging. So don't be in a hurry to say it is not homogeneous. It is. Check this one out. dy all over dx the same as x squared plus y squared all over xy. There are equations that you can easily rearrange and they become homogeneous. What have I done? I've taken this x here. Now, I will ask, is it homogeneous or not? Like that. Is it homogeneous or not? So, is it homogeneous or not?
Yes.
Ferdinand, is it? Ferdinand?
Yes.
No, it is. So don't be in a hurry. Don't be in a hurry to nini. There are equations whereby you just need to manipulate them. Just to have, if you can just have the dy on one side, it will be easier for you to be able to check. So what I can easily be able to suggest to you for now, for to check for such equations, so at least you don't miss them out. This is what I can be able to propose. So I propose you make dy over dx the subject. The subject, the subject of the formula, then check if it is homogeneous. This is what I will need, so at least you're not caught off guard. So I propose you make dy dx the subject of the formula, then you can easily be able to be guaranteed that it is homogeneous. Is it clear? You can say something. Is it clear? Someone to say, is it clear? Is it clear? Okay, sour. So let's do this one. This is the final example I'm doing because I don't want the video to be that long. You can be able to follow now up on the rest. And I've done a very hard example, so it will be a bit easier. So this is what we have. dy. This is what we have. Dy all over dx is equals to x squared plus y squared all over xy. Let's cross multiply. We cross multiply quickly. We cross multiply. So that one and that one, and this one by this one. So you'll have xy dy is equals to x squared plus y squared. Brackets are very important, the x. So I've cross multiplied. So when you cross multiply, we can easily be able now to let y be vx, and then dy will be given by v dx plus x dv. That's what we shall be able to replace with. So whatever that I have here in yellow is what I'm replacing. The first one is that one, the dy there, I replace. Then again, I'll replace even the y, and then I'll replace the y squared there. That's what I have. Those are the terms that I need to replace. So let me replace and see what I'm getting. Replace and see what we are getting. This one is just arithmetic. So we have x, our y is vx, and then our dy is what? V dx plus x dv is equals to, I have x squared plus vx will be squared, brackets, and then dx. When I open up the bracket, this is what I'm supposed to get. Open up the bracket. So you have two v's and two x, so you'll get x squared v squared dx. And then the other one you'll get x to the power 3 v dv. This other side you'll get x squared dx. And this other side you'll get v squared x squared dx. Now, can someone see the terms that will need that will reduce to zero? This one, check this one out. The one that I've done in purple. The one that I've done in purple, that term there, and this term. What can you tell me about those two? Those terms that are in purple. What can you be able to tell me about those terms? I kindly refresh the board. Okay. Someone tell me what are you seeing about those terms? I'm refreshing the board. Now I've refreshed the board. Oscar, are you okay now?
Yes.
Oscar, so this is what we had, Oscar. I cross multiplied. After cross multiplying, this is what I got. Then I replaced back the terms that are in yellow. I replaced with vx and v dx plus x dv. So this is what I had. This one. When I have this one, I open up the brackets. When you open up, you'll get x squared v squared dx plus x to the power 3 v dv is equals to x squared dx plus v x squared dx. That's what I'm getting. Now I'm asking about the terms in purple. You can be able to see they are identical. It doesn't matter the term that you start with. So they are identical, and they're on the opposite side of the is equal sign. So that one will go to zero. So these two will go to zero. So what I remain with is this. Check. I remain with x to the power 3 v dv is equals to x squared dx. So now we just need to ask ourselves, can we be able to integrate these ones? No, we can't integrate. Why? Because of this term here. On the one that I've circled, on the right hand side of the dx, it is okay. That one is okay. But the problem here, I have a dv and I have a term of x to the power 3. So what do I need to do? I need to remove it. How do I remove it? I divide both sides by what? By what? X squared all over x to the power 3. Then dx. And when you do that one, you remain with what? V dv is equals to 1 over x dx. When you integrate v, what do you get? Someone to try when you integrate v. Now we integrate both sides now. When you integrate v, what do you get? What do you think you'll get? V?
Mwalimu, I have a question.
Yes. Ask.
So there, when we were opening the bracket,
Yes.
will you please revive that place so that I can be able to understand, because I have some issues
there.
Okay, opening up the bracket. Okay, so somebody is asking how we open up the bracket here. So we have x times v times x times v times dx. So how many x do we have? We have this one here. Let me circle it. The first one. So we have that one x. We have that one x. So it will become x squared. To get up to there. Then we have here the v and the v. We shall get v squared. That's the first one. Now, again, we have everything that is outside here. Everything that is outside here. Again, we come and take here, we have here x times x. You get x squared. To get up to there, then x squared times this x here. What do you get? X to power 3. Then this v, you can be able to see it will come there. That v will come there. That v will come there. And that's what we have, v. Then this other one, v, you get v squared. X, we are squaring it. You'll get x squared. Then you multiply with the dx. X squared, you multiply with dx, you get what? Dx. Have I tried to answer the question of the opening up of brackets? The opening up of brackets. Is it okay, the opening up of brackets? Masinde?
Yes.
Yes, just multiply the terms that are outside and then you multiply now because there's a bracket here, you multiply with that one and you'll be able to get. Now, after you have multiplied, you can be able to see here, I have x squared, v squared. So we said what here? These two terms are identical. They are identical. They are identical. So if you bring one on the right hand side or on the right hand side or on the left hand side, they will reduce to 0. So it's as if they reduce to 0 because they are identical. So whatever that is remaining is whatever is not in purple. And then now from there we separate the variables. This x to power 3 has to come this side. It has to come because you can't integrate. This one has to come this side. This one has to come there. And the only way it can be able to come there is by dividing both sides by x to power 3. So this side it will not be there anymore. So it will remain with what? X squared over x to power 3. Then here you will remain now with v dv. This is what we wanted. Like terms together. You'll have 1 over x dx. Now you integrate now. And that's why I was asking, when you integrate v dv, what do you get? No one got an answer. Let me see. Oh, someone got it. Okay, someone got it. So when you integrate that one, just like x, you'll get v squared all over 2. Integrate ln 1 over x, will get ln x plus c. The c, I'll not call it ln x because there's no other ln on the v. There's no ln, so it will remain like that. But you go back to the but. We have said y is equals to vx. So it means that v is equals to y over x. So our final answer will be y over x squared all over 2 is equals to ln x plus c. So you must replace back the v. I don't know if I do the final example because I'm seeing people are still having an issue, or are you okay up to there? You can be able to look at the notes. At least I've given you an overview. It's not a must to understand fully. Yes, Benjamin.
Yeah, I'm
Mwalimu, I
okay
have
from
a
my side.
question.
You have a question? Okay, ask.
My question is, I thought when we integrated V, we wrote
Yes.
plus C, and also when we integrated the other side, we also wrote plus C. So I think that the C will cancel.
No. When you introduce the concept of integration, you only introduce on one side. You don't introduce on two sides. Only on one side. So I never introduced two C's. Again, I only have one C. I only
Okay, now
have
I
one
get
C.
it. I
You
get it.
introduce,
Thank you.
introduce the C on only one side. Okay. You know, with a final example. Okay. Let me check now for final. That is, I want an example that is not there in your book. and an example that is not there in your book, so at least the one that I've given you, so at least you can be able to follow. I look for one. Okay, there's one that I've seen. Let me read quickly. There's one that I've seen. This is number now 5. dy all over dx is equals to y minus x, y plus x. That one there. It will be a bit lengthy, but it is still doable. So we can start. Is it of the same order? Is it of the same order? Let's start from there. We start from there. Is it of the same order? This one is easy to see. All of them are of power 1. So it is of the same order. Yes, okay. Let's now do this one now. We cross multiply. Multiply, so we shall get y plus x. This is what I'm doing. I'm doing that one and I'm doing that one. Dy is equals to y minus x dx. From there, we said to introduce y, let y be vx and dy to be v dx plus x dv. X dv. So I replace that one there. So I'll get our y is what? Our y is vx plus x, and then our dy is v dx plus x dv is equals to, again we have x minus x. So that's what I have. I have replaced where there's a what, there's a y, and where there's a what, where there's a dy, I've replaced together. So open up the bracket now. Open up the bracket. Tell me what you are getting when you open up that bracket. Open up the bracket. So I'll multiply this one with the whole of that one. Again, I multiply the x with the whole of that one. That's how we do it. So the first one, I'll get the vx times v. So I'll get v squared x.
Not board.
The board. Okay.
Yes.
Okay, let me refresh again the board. Can you see the board now?
Yes.
Can you see the board?
Yes.
Okay, so okay, I'll go back to what we have done. So we have said it is homogeneous, 1, 1, 1, 1. So I've cross multiplied. That's what I've gotten. Y plus x dy minus y x dx. Then I've introduced my y vx and dy v dx plus x dv. So I've replaced where there's a y with vx, where there's a dy with that one. So you are on the verge of opening up the bracket to see what we are getting. So the first one, I have v times v, I'll get v squared. Then here I'll get x dx plus. I multiply vx times x, so I'll get v x squared dv. And then I multiply the other one, I'll get xv dv is equals plus again x squared d, sorry, xv dx. That one is wrong. This one is wrong. This one is supposed to be dx. It's supposed to be dx. So dx. Then the final one, x squared d dv. This is one when I open up the bracket, I'll get what? Vx dx minus x dx minus x dx when I open up the other one. So I believe there are some terms that will cancel. Let me highlight the terms that will cancel. Check the one that is in purple. That one there and this one here. They are similar. The one that are in purple, they are similar. And they are on opposite sides of the equal sign. So that one will go to 0. So let me see what I will remain with. So I'm remaining with v squared x plus vx squared dv is equals to, sorry, supposed to be plus x squared dv is equals to minus x dx. That's what I'm remaining with there. Let me put just plus this one. It's plus. This one is plus. From there, we say we bring like terms together, the dv on one side and the dx on the other side. So we bring the dv on one side and the dx on the other side. So your preference, whatever you love. So let me remain with the dv this side. So I remain with vx squared dv and then plus x squared dv. Then on this other side, I'll have negative x dx minus vx x dx. So this one I'm bringing like terms together. The dv on one side, bring dv and dx on opposite sides. So I'm bringing the dv and the dx on one side. Then I'll factorize now. So what is common there? Factorize. So what is common here, I believe, is only the x squared and the dv are common. You can be able to see. So the x squared, I can be able to remove it, and the dv I can be able to remove it. So I remain with what? V plus 1. On this other side, what is common there? The x is common and the dx. So I can be able to remove the negative x and dx. So I will remain with what there on that side. If you factorize, when you factorize, this is what I'm remaining with. Check again. I have negative x, and x is the one that is common. So when I'm factorizing, I'll get what? Let me factorize it as a negative. It will be the remain as a negative x and dx. So here I remain with what? Only 1. Is it only 1?
Yes.
1 plus, Cindy, 1 plus, say, 1 plus v squared. That's what I'm remaining with. Confirm. That's what I'm remaining with.
Yeah, it's correct.
Okay,
Correct.
so now we can move on now to separation of variables now. Separate now. So we separate. So on the side of dv, we don't want the x squared. On the side of dx, we don't want this one. So we shall remain with what here? So here we shall remain with what? V plus 1. V plus 1 all over v squared plus 1 dv. On the other side, we shall remain with what? Negative x all over x dx. So I've check again. I've taken this one. I've taken this side of the dv, and then this x I've taken on the side of the dx. So you must divide. You must always divide. So now we ask ourselves, how do we do it? How do we integrate such? This side is very easy. This one is supposed to be x squared. That one is easy. So how do we integrate that side? So the integration is the most difficult part. Can we agree on that? That the integration is the most difficult part. So this one I'm remaining with the v plus 1 all over v squared plus 1 dv is equals to integration of negative 1 over x dx. So the v are the ones that are hard to integrate. The v are the ones that are hard to integrate. How do you integrate such? This one I will leave it hanging. You'll be able to give me the answer next time. So I'll give you a hint. V plus 1 all over v squared plus 1. If you don't know how to integrate, you are done. So I'll distribute the denominator. It's easy to distribute the denominator. This is what I'm getting, this one. I'm giving you a hint of how to solve that one. Ni rahisi sana, but you must be careful. It is very easy, but you can't see it if you don't remember integration. So v plus 1 all over v squared plus 1, this one, if you distribute, you'll get v all over v squared plus 1, and then plus 1 all over v squared plus 1. So you can easily be able to distribute the denominator on the first term and the second term. Then the integration now becomes a bit easier now. This one. So you integrate this one, integrate that one. Integrating in terms of what? dv. In terms of dv. So I was able to distribute the denominator. I have v plus 1. So you can be able to see I have separated the v and the 1. So the first term here, we can use substitution, this one. This one you can be able to use substitution. Substitution. That term you'll be able to use substitution. Very easy. That one substitution will be able to work for this term here. That one here. Because when you differentiate v squared, you'll get 2v. So it will be able to work. This one, I believe on the table of integration, we did this one, the table of integration. We integrate 1 all over x squared plus a squared dx. Can I remember this one? You had plus. Is it the tan inverse or is it the ln? Someone remind me. Is it the tan
Tan
inverse?
inverse.
You are sure?
Tan inverse.
You are sure?
Tan inverse.
You are sure?
Yes.
Let me. Can I remember? I believe it is tan inverse. So you are getting 1 over a, the tan inverse of what? X over a. That one then. We integrate that one. So when we are using substitution, the other one we are using what? The tan inverse. So when you use this substitution, when you differentiate, we'll get 2v. So there's a 2 that will remain somewhere. So integrate the first part. So let me do this one now. So when you integrate v all over v squared plus 1 dv, using substitution, you're supposed to get a half ln v squared plus 1. That's the first one. The second one that we are doing is the integration of 1 all over v squared plus 1 dv. When you do this one, we are getting what? Tan inverse. So you shall just get tan inverse of v. We are done with that one now. And we had another term here. We had the integration of negative 1 over x dx. On the right hand side, you'll get negative ln what? Ln x. Negative ln x. So we have everything that we did now. So the final answer will be a half. My body is. I hope you can still be able to follow. So the body is this one now. So I'll have a half. The first answer we have gotten is what? ln v squared plus 1 plus the tan inverse. The tan inverse of what? The tan inverse of v is equals to negative ln x plus now what? You just add 1c. But v is equals to y over x. So you replace back the value of v. You replace back the value of v, and you shall be able to get the final answer.